Question 6 asks, in view of the answers to questions 4 and 5, how do you explain the results in questions 1 and 2? Remember, questions 1 and 2, they had digits of precision were 10 to 15 or 17, and they were giving the wrong answers. So getting 0, we got 10 over 3 on this one. The other one we got undefined. So now it's asking, how do we come to terms with that? So what's our explanation for why the answers in the question 4 and 5 gave 1? Yes, questions 4 and 5 gave 1, as well as 3 gave a equals to 1. But how do you explain the results in question 1 and 2? And yeah, because we were using the same CAS, the same Wolfram Alpha to solve it. Yeah, actually, I didn't actually use the Wolfram Alpha. I used the Desmos, Maple, and the Excel, or the Maple from the Solutions Manual. But if you go to Wolfram Alpha and you get this giant formula, sine tan, and then plug in 0.001, and then minus tan sine, and then 0.001, even Wolfram Alpha gives you the results undefined. So even this one's undefined. So yes, fascinating stuff. So that would be undefined, just for reference, to show that I had that included. But anyways, let's keep going further. And now let's explain away what this would mean. So the strange results with only 10 to 17 digits of precision from questions 1 and 2 must be due to the fact that the terms being subtracted in the numerator and the denominator, because remember there's a subtraction there, are very close in value when absolute value of x is small. Thus the differences are imprecise, have a few correct digits. We can see this is the case by comparing the graphs of the terms in the numerator as well as comparing the terms in the denominator. And when we zoom in near x equals 0, we see that the values of the terms are almost identical to any level of zoom we get. So if we graph sine 10 like this and you zoom in, they're almost identical. This is 10 to the negative 18. This is beyond the precision of the earlier calculators. And then going further, so if you do the same thing for the denominator, so inverse sine of x, inverse sine of inverse tan of x, and then the inverse tan of inverse sine of x, we get the same thing. You graph those ones together, it looks absolutely identical. And you zoom in, it's very, very close, even at the 10 to the negative 18, so the 18 digits precision. Or the 18-digit zoom. And then even if you do it for each terms, even the ones inside, so sine of x, tan of x, inverse sine of x, inverse tan of x, so the graphs all look like this. So remember the graphs that we had earlier drawn. So this is the red one is the vertical red one is the tan of x. Yeah, so it has a period, keeps going on and on. It's periodicity or periodicity. In other words, just repeats. And then, then a dashed line, red line is the inverse tan of x, goes like that. And again, they're all very, very similar at x equals 0. And then we have the black one is the sine of x, dashed black one is the inverse sine of x, exactly like our graph. And then if you zoom into the 10 to the negative 18, we get exactly all of them look exactly the same. Thus, the terms themselves are near identical when zooming in beyond even the level of precision of most calculators. To illustrate what this means, consider the following calculations of 10 digits of precision. So if we have division, here's the exact calculation, but let's say you only have 10 digits precision. And so this is, let's see, that's 10. This can be, so including the 0 there, it's going to be 5. And then 1, 2, 3, 4, 5, so that's 10. And then beyond that is 279, we have this 111. So 1, 2, 3, 4, 5, and then 279, 111. Subtract that, we get, divide these out. So if we divide for division, we get 1.00013608626. So division is all right. You get pretty much 1 with 4 zeros there, a lot of zeros. And then if you do the calculator with 10 digits of precision, these are cut out. 279, 111 are cut out. So we get this 0.0001234 divided by, we get 1. So we get 1, which is still close to this answer. Yeah, so it's still very close, 1 and 0.0001. But then when you do a difference, we get the exact one here is the exact same thing, but we're subtracting. We get 000 all the way to 168. So 279 minus 111, the only thing different. So we subtract this 1, so 1688. And then, yeah, we get this one, and this, also this calculator is used, the Google calculator. So anyways, yeah, so that's the exact 0.0000168. But then if you do the calculator, we get this 1, 2, 3, 4, 5. Yeah, these cut out these endpoints. these last terms. So we get 1, 2, 3, 4, 5 subtracted by 1, 2, 3, 4, 5. We get 0.0000. And dividing differences that are rounded to 0 is undefined. You get the indeterminate form of 0 over 0. So that's why even Wolfram alpha gets you a 0 over 0. And that's why they get undefined over there. It's fascinating stuff there. So hashtag interesting stuff.